Swayam Prabha. Digital India. Educated India.
So yesterday we were discussing about something on batteries and some initial experiments and the history about the electrochemistry. Now today we will be discussing something on fuel cells, supercapacitors as well as electrolyzers. So is all batteries are, if you are using batteries in electric vehicles, is it green? Is it completely green if you are using an electric vehicle with batteries? Why? Yeah, the place it will be metallurgy or sort of things will be happening, purification, all those things will require a lot of energy. There we will mainly use the crude. So then the production side will be like more of environmental polluted. So as in using batteries is not the correct way of getting rid of this carbon material. So hydrogen may be a good source. Why? Because hydrogen is a clean source of energy. If you will burn hydrogen, you will get water as a byproduct. So this is the reason why, and it is a huge amount of energy source. So if you will see the amount of energy, gravimetric energy density of hydrogen is around 120 megajoule per kg. That is around 2 to 3 times higher than that of petrol or diesel, crude. So when you compare this one with lithium ion battery, how much it will be? Lithium ion batteries. Okay, what is the energy density, gravimetric energy density of lithium ion battery? Approximately.
Ma'am, how can we compare 1 kilogram of hydrogen to 1 gallon of gasoline? Isn't that mass to volume comparison?
Which one?
Hydrogen, 1 kilogram, gasoline, 1 gallon.
It's like gallon is, I have to see actually.
Yeah,
Yeah,
but
I
how
have
much
to
of fuel do you have?
Yeah, it's 1 gallon of this one. It's the volume actually. So can you please tell me what is the energy density of a lithium ion battery? It is around 200 watt hour per kg. So what will be the in joules? How much it will be? How you will convert watt hour into joule? Yeah, how you are converting it to watt hour to joule? What is what? What is what? Other than that? That is, what is current you can tell? Right? What is volt? Yeah. Sorry, coulombs per second, okay. Okay. So that is equal to 1 watt hour is equal to 3600 joules. Okay. So I have 200 watt hour per kg for lithium ion. So it corresponds to megajoule per, right? So if you will compare So this much difference is more than 100, right? So then hydrogen is a, then why hydrogen cannot be used as a fuel? Huh? Huh? What is the problem related to storage? So petrol is not flammable? Yeah, you have to compress the hydrogen. So its volumetric energy density is lower. When you compare with the crude, its volumetric energy density is lower, but its gravimetric energy density is high.
Ma'am, isn't the cost of producing green hydrogen still quite high?
That I will discuss with you. Okay. When we were going for the electrolyzer, I will discuss the cost and everything of producing hydrogen. For an approximate this one, if you are doing with an refinery, from refinery by burning the crude, it is the lowest cost available hydrogen you can get. That is around 100 rupees per kg of hydrogen. So that's it. So how we can utilize the hydrogen as a fuel? So one of the ways using the fuel cell. So fuel cell is any device where you have a fuel which is oxidized at an anode in an fuel cell and an oxidant which is get reduced in an cathode of the fuel cell. So if the fuel cell contains, actually at the anode and the cathode there is a catalyst available for the oxidation and the reduction of the fuel as well as the oxidant. So usually in a fuel cell different types of fuels will be used. So I'll discuss about it later. So we in a fuel cell then we have an anode which is active for the oxidation of the fuel and the oxidant to reduce, and there is another electrolyte medium or a medium where you can have the cation or the anion exchange will be happening. So it's like an electrolyte. It can be a membrane or a liquid electrolyte or any solid. There are also solid substances available for the conduction of the ions along the anode and the cathode. So depending upon the different fuels used, fuels and the membranes used, we can have different types of fuel cell. One among them is the solid oxide fuel cell. This is getting lot of attention these days because now people are trying to get low temperature hydrogen, proton conducting membranes or oxides for this particular type of solid oxide fuel cells, and this fuel cell is highly efficient. Presently it is working in a very high temperature, that is around 900 to 1000 degrees Celsius, but now by research people could be able to get around 500, less than 500 degrees Celsius. So another one is the port. The solid oxide fuel cells are mainly used for storage applications. Now the one which is commercialized mostly is the polymer electrolyte fuel cells. Here actually the fuel used is the hydrogen and the oxidant is oxygen, and the membrane used is a polymer conducting membrane which will actually conduct the proton. So this is actually a proton exchange membrane fuel cell will look. So at the anode hydrogen get oxidized, that is H2 will convert into H plus, and at the cathode oxygen get reduced and forms the water, and the H plus ions which will migrate from the anode to the cathode will interact with the oxygen, reduced product of the oxygen and forms the water. So this is how the working. So this is how an fuel cell is constructed. This is a single cell. So you can have two bipolar plates actually which is having a serpentine sort of design. These serpentine designs are basically for the uniform distribution of the gas. Actually you are passing some gas, hydrogen and oxygen from both sides of the cell. So this oxygen has to have a proper distribution along the catalyst surface or the electrode surface. For this serpentine type of designs will be there on the bipolar plates, and it is also conducting medium actually. It's a conducting for the electron transfer along the reduction and oxidation actually. And the next is a GDL layer. GDL layer is actually a layer which will allow the passage of the gas through this GDL layer. Actually, it is a porous membrane. It will allows only the gas, not any liquid or any other products to pass through. So it is a porous membrane. You can see this is how a GDL will looks like. And this is the proton naphthalene membrane. Usually used proton exchange membrane in a PEM fuel cell is actually naphthalene membrane. Actually, naphthalene membrane is this fluorinated sulfonate membrane actually. This is the chemical formula of this one, and it looks like this.
Ma'am, what is the expansion of GDL?
Gas diffusion layer. And how this this is a membrane electrode assembly. Again, this membrane electrode assembly is formed by there is a catalyst layer, and the membrane will press together so that the contact between the membrane and the catalyst will be very strong, so that there won't be any IR drop. So actually the membrane is actually an ionic conducting membrane, and along this one only the proton will conduct. So this is how an fuel cell will looks like, and and working of the fuel cell is like that. When we will pass the hydrogen gas along this one, along a bipolar membrane, along the GDL layer, only the hydrogen will goes, no water, no other, only hydrogen gas will go, only any gaseous product will be goes inside the ME assembly, and at the MEA, at the anode, hydrogen will get oxidized and it will pass through the naphthalene membrane, and then will reaches to the cathode surface where the oxygen get reduced, and it will combine the reduced product of the oxygen and forms water. So this is how a PEM fuel cells will work. See, I was telling these two reactions, actually hydrogen oxidation as well as oxygen reduction. These reactions are not that easy to happen, especially with the oxygen reduction reaction. It is a multi-electron transfer reaction. So for that reaction to happen, you need a catalyst. So usually used catalyst is platinum. Platinum is used as a catalyst in PEM based fuel cells, and platinum, as you know, it is very costly. So commercialization of one of the major drawback of using fuel cell or PEM based fuel cell is the platinum based catalyst, because the cost of the device is mostly because of this platinum catalyst. And platinum is known as the best catalyst. No other catalyst is found up to now. It is the best catalyst you can know for the hydrogen oxidation as well as oxygen reduction reaction. So why you need a catalyst? So this is a particular polarization curve for a fuel cell, IV curve. Okay, so what happens is that when we are applying a load, how your voltage is dropping of the voltage is lower, then your catalyst having a higher power density, or it can have a higher energy density. These are the two different catalysts. If you can see this particular black and the red, this is very active as compared to the red catalyst. Why? If you will see, the initial drop in the current in the red is more. How we can say it is a best catalyst? Black is better than red. If I will apply a load of around 300 milliampere per centimeter square, the red catalyst won't give any voltage, right? Or it won't perform any work, or you cannot perform a higher current, you cannot give a higher load to this particular catalyst as compared to the black catalyst. So in a polarization curve you can have three different areas. One is the activation loss region. This is actually due to the catalyst activity for both oxygen reduction and hydrogen oxidation reaction. And the next region is due to the ohmic loss. This ohmic loss can be due to the contact resistance between the electrolyte and membrane and your catalyst, and the catalyst conductivity as well. Okay. The third area is called as the concentration loss region. It is due to the diffusion of the species to the electrode surface. It again depends upon your catalyst activity. So these three regions are there, and depending upon the performance of the catalyst in these three regions, you can have a good the performance of your fuel cell. So you need a catalyst to have the fuel cell to work in a particular efficiency. So, if I am using a platinum catalyst, as I told earlier, it is too costly. So, people try to decrease the amount of platinum, because platinum is only required on the surface. Electrochemistry is something happening only on the surface, right. So, they try to decrease the amount of the catalyst by making thin films of platinum, then again making platinum particles which is decorated on the surface of a conducting substrate. For example, carbon is mainly used because carbon is having a higher surface area. So, you can decorate the platinum particle on the surface of the carbon, so the entire area will be covered by the carbon and you have a uniform distribution of the platinum, you will get the same efficiency like that of a platinum, bulk platinum. So, you can actually reduce the amount of the platinum by using this particular method. But again, platinum is prone to surface poisoning. Actually, if you have a very low amount of carbon monoxide or carbon dioxide in the hydrogen gas, for example, he was asking what is the hydrogen cost. So, for example, if I will use a refinery hydrogen actually produced by burning a crude. So, crude will contains hydrocarbons, right. So, it will contains lot of impurities like carbon dioxide and carbon monoxide. If I will use the same hydrogen from the refinery as an fuel, actually what happen is that this carbon monoxide or carbon dioxide can poison the surface of the platinum. It will adsorb onto the surface of the platinum very strongly. So, again the hydrogen oxide, the required reaction, actually what happen is that you have a platinum surface when hydrogen will comes, it cannot see this platinum surface because it is poisoned by the carbon monoxide. Again, the interaction of the hydrogen with the platinum surface is not possible. Actually, it happens like this: when hydrogen will comes, it will interact and this bond will break and it will forms H plus and it will desorb from the surface. This is how it happens. So, it cannot see the surface, this oxidation reaction won't happen. So, it is in that case we need something like other than platinum, or you need something like platinum. If there are research like using ruthenium, ruthenium is another metal which can actually from the HOH and it can react with the oxygen, hydrolyze water and forms an like this. So, if there is a carbon monoxide, it will evolve from the surface as carbon dioxide. So, platinum ruthenium alloy can decrease the poisoning of platinum surface. But again ruthenium is costly. So, people are trying different methods like for example, they tried something like titanium nitride. It is a ceramic material, on the surface platinum is grown. That titanium nitride also having the same sort of behavior. It can actually hydrolyze water and forms the OH and it can recover the platinum surface. So, this type of research is actually going. Many refinery like Indian Oil, HPCL, they are trying to use the refinery hydrogen because it is lower cost and it is easily available in their refineries. So, they are trying to use this particular hydrogen which is having some amount of carbon monoxide used as a fuel. But the major problem they are facing is the platinum is getting poisoned because of the carbon monoxide in the gas. So, they are trying to improve this one by using some alloys like ruthenium, titanium nitride, everything, and the research is going on. If they could able to get success with that one, it is one of the good way of doing an fuel cell using a refinery hydrogen because it is less costly. That hydrogen is less costly as compared to the other hydrogen which we are producing. So, again the stability of the catalyst is also an issue. For example, whatever I was telling is that a carbon surface platinum is decorated. Actually, this carbon surface getting oxidized during the process and this platinum is getting dissolved from the carbon surface. Once the platinum get dissolved from the surface, it will goes to the membrane. It will start sticking onto the membrane, and you will have lot of other backward unwanted reaction happening, and it will actually reduce the efficiency of your device. So then now people are trying to use an anion exchange fuel membrane. Actually this anion exchange membrane uses an OH minus ion conducting membrane. So it is an alkaline based medium. So it was found that in alkaline conditions, this oxygen reduction reaction that I was telling, it is the most difficult reaction happening in a fuel cell. So oxygen reduction reaction is very facile in an alkaline medium. So many carbon based catalysts has been found to be very good in alkaline medium for ORR. So you can avoid platinum and then you can reduce the cost. So AEM based fuel cells are getting attention because of we can use many non-precious based catalysts for the fuel cell application, and the cost of the device will be very low. So this is, maybe you guys might have seen this news. It was there in 2022. Toyota has this Mirai, Toyota Mirai came to India. Petroleum Minister was driving this one. It was there in 2022. This is a car. You can see it is working with PEM based fuel cell, and the cost is very high, 37 to 55 lakhs. It gives a range of 647 kilometer. Per charge, single charge means per one by filling in that can the tank of hydrogen for the first time, for one time. So this is how the fuel cell will be arranged in a vehicle. So you can have the fuel tank. Actually the oxygen is coming from the air. Whatever the oxygen used is coming from the air, and you have to carry an hydrogen tank. So this is the tank of hydrogen, and you can have a very small battery. Like the way you have an SLI batteries, here the batteries are used for your start. You need, because this fuel cell is having a very low voltage. It's around, the voltage of a fuel cell is only 1.23 cell voltage, the maximum theoretical voltage, and the obtained up to now is around 1 volt. So you need a high power application, you need a lithium ion battery. So there is a small battery pack, and you have the fuel cell here, and these are the motor, other systems. And this is a Tata car. This car, Tata bus, actually this bus, they are trying to use the refinery hydrogen. Tata got an approval for this road test by India government recently in 2022. 2 of their buses are along with Indian Oil, they are trying to use the refinery hydrogen and trying to drive this vehicle actually. These are the 2 trains which is recently launched in Germany. Actually you know that in Europe there is a lot of problems related to the crude because of the war between Russia and the Ukraine. So they recently launched these 2 fuel cell based train in Germany. This Siemens and this particular company actually produce these type of trains. So up to now we were telling about hydrogen as can be used as a fuel, but how we will get the hydrogen. So these are the different sources where we can get the hydrogen. So if we will say green hydrogen, it's not the electrolysis of water. Actually the energy you are putting for that electrolysis of water should come in renewable energy sources. So you are applying some voltage, right, for electrolysis. This should be come from renewable source. Otherwise, if you are using some power directly from the consumer power, it's actually is coming from coal. Most of the production of electricity in India is from the coal. So you can only if it is coming from a renewable energy source, we will say that it is a green hydrogen. Otherwise, it is from these are the different color coding you can see. Purple is from the nuclear, if you are getting the electric power for the voltage from the nuclear, and yellow is actually the usual coal power. So these are the different color coding used for different hydrogen production, and gray is from the refinery actually. Gray hydrogen is from refinery because you have lot of carbon dioxide produced during the process of hydrogen production. So this is how an electrolyzer works. So what will be the negative electrode in an electrolyzer? Where you have to apply a negative voltage? Where hydrogen is generated or oxygen is generated? Or what is the anode in an electrolyzer? Huh? Which will be an anode in an electrolyzer? Huh? What is an anode in an electrolyzer? What is an anode in a battery? Lithium ion battery, which is the anode? So what is the sign of that electrode? Is it negative or positive? Anybody? Huh? What? Lithium ion battery. It's positive. Anode is positive. Okay. Anode in any electrochemical system, it is the electrode at which oxidation takes place. Please remember, anode is an electrode where oxidation takes place. Okay. So lithium is the place where you will get Li++ electron, right? So this is the place where your oxidation takes place. If, what does it mean? This electron will goes here, so it will be negative in a battery. Okay. Cathode will be positive, right, in a battery. And in an electrolyzer or in a fuel cell, you have hydrogen oxidation and oxygen reduction, right? So here what happened? This is the negative electrode, or here hydrogen oxidation takes place is the anode. Okay, this is the anode and it is negative. Okay, in a battery, in a fuel cell where the oxidation takes place, anywhere in an electrochemical system where the oxidation takes place, it is an anode. In a battery and fuel cell, it is negative electrode. Okay, but in an electrolyzer, water is getting split into, that is H plus OH minus, this H plus is getting H2. So here the electrons will be coming. So you have to apply negative voltage, sorry, right? You have to give some electrons to the H plus, right, to reduce it. So it will be this will be the cathode and it will be negative. Okay. And here anode is actually, in an electrolyzer, anode is the place where water oxidation takes place or oxygen evolution is taking place. So that is actually, what is the sign? What is the electrode? Positive or negative? Huh? Again so much. Cathode is any place where you have the reduction takes place. So water electrolyzer, where is the reduction takes place? H plus is converting into H2. So there is the place you have the reduction, right? So basically fuel cell if you will reverse the fuel cell, you will get the electrolyzer. Fine? There is no confusion, right? Okay. Then in a Daniel cell which is positive. Daniel cell which is positive. Huh? So while charging which is positive? Oh, is it so? So when you are charging, you will charging, you will make it like this. So why? What happened in a Daniel cell? Discharging copper is positive, while charging which is positive? Yeah, again copper. Because while charging it will be an electrolytic cell, right? When it is discharging, it is a galvanic cell. So it is like this only. So fuel cell while discharging, electrolyzer while charging. So while charging and discharging, hydrogen wherever it is used or consumed, that is the electrode is negative. That is in a Daniel cell as well, any batteries. So while you have the battery reaction happening, discharge, anode is a negative electrode. And charging, it is the cathode, and again it is a negative, right? So that is how. So while charging the battery, you don't have to change the terminal. It is the same. Okay.
So even in a galvanic cell, it's like the fuel cell, like discharging thing.
Yes. Any galvanic cell or fuel cell, you are actually the cell is giving some electrons, and during fuel electrolyzer, you are making the cell to work. So you are putting some voltage. So it is like a charging of a battery actually, electrolyzer. Okay. So you can have again the reactions are in an electrolyzer is actually opposite of what happens in a fuel cell. So you have the water which will give H2 as well as O2 in an electrolyzer. And during fuel cell you will give this back. So now people are trying to actually making a fuel cell reversible. So that is also a type of reversible fuel cell. That is also in research. I mean, there are a lot of work going on how to make a fuel cell reversible. So that you give the hydrogen, you produce the water, again you use the water, again produce the hydrogen. That is how the work. It's like a lithium-ion battery. So you use you can recharge it back.
Ma'am, but then according to thermodynamics, you can't just keep getting the same energy again and again. Let us say that you had a system where you had a fuel cell that produces energy, and then use that energy to produce the fuels again and feed that back into the fuel cell. You can't keep doing this forever according to thermodynamics. So that means
why? One is a spontaneous process where you get the electrons, right? Another one you have to give it's a non-spontaneous.
As the number of cycles increase, you'll be losing energy.
Yeah, you are producing same thing, right? In a battery, you will have some loss. Any batteries you don't get an efficiency of C. If you will see the Coulombic efficiency. Coulombic efficiency is the charge during the discharge you will get how much charge or the current or capacity. How much capacity you get during a discharge won't be same as you will get during charge. So something like if you will do something like this, so you will have some loss. So it is a capacity versus voltage. Some loss will be there. So if it is very high, even if it is some 90% is also, you won't get, the number of cycles will be not more than 500. So you should have something like 99.99 something. Complete reversibility. Okay. So it is an electrolyzer where you actually produce the hydrogen and oxygen. So there are two different types of electrolyzer, you can say PEM fuel cells, PEM electrolyzer as well as a AEM electrolyzer. So again, in a PEM electrolyzer you use a naphthalene based membrane where you have a proton. Actually what happens is that during the here hydrogen will be hydrogen will be generated, right. H plus ions will coming and it will be water will get this reaction will be happening. First oxygen evolution water will oxidize to oxygen, okay. So then this H plus ions will be generated which will pass through this PEM membrane to the cathode, okay, where your hydrogen will produce. So this PEM and proton will be moving along the membrane, and in the AEM based electrolyzer actually OH minus ions will be moving. So because here this is the reaction. So when you are having water will get reduced to form OH minus ions which will goes here at the anode and it will be get liberated as oxygen. So this is how a PEM and an alkaline membrane fuel cells electrolyzers will be working. So this is a work which we done in is actually an AEM electrolyzer we developed in IIT Trivandrum. So this the cell looks like this. So actually the cell, how we will assemble the cell is you have an anode cathode, in between this yellow color is actually an AEM electrolyzer, AEM membrane which will conduct the OH minus ions. So I think, see this is how the hydrogen gas is generated. So what we will do is we will actually circulate an electrolyte along the anode where the oxygen evolution is happening, and we will collect the gas through the where the hydrogen is generated, that is the cathode from where the hydrogen is generated, and you will collect in an inverted funnel so that you can measure the amount of hydrogen generated in the time, and we can quantify. Actually whatever the membranes you are using in an electrolyzer should only conduct the ions, it should not transfer any oxygen or hydrogen gas. If they will mix, you cannot get the separated gas. So you need a membrane which is having there is no conduction of any gas, it should be porous enough only for the conduction of the ions. AEM and this is an AEM based electrolyzer similar with PEM based electrolyzer. Actually PEM is more effective as compared to the AEM electrolyzer. Yeah, again the naphthalene and platinum is used as a catalyst, it is costly. This is an it's not an the catalyst we developed is a non platinum based catalyst. Yeah, cost effective. Usually nickel based catalyst you can use, yes. It's that fast. No, you can the amount of hydrogen produced or the amount of current we were getting is too high. So the amount of current you are getting actually correlated with the amount of hydrogen, right? So it's too high. You should have actually very high amount of hydrogen produced. So so everything is clear up to this. So next I'll move on to something like electrochemical capacitors. So what is the difference between, what is a capacitor actually? How it is stored? How the energy is stored in a capacitor? How a capacitor is constructed? Yeah, parallel plate, two metal plates. Huh? How the opposite charge is getting? It's an energy storage device, right? How the electrons are there? What is the means principle in an capacitor? How the charge is stored? Okay, you have a dielectric medium. That air can be a dielectric medium. You know the electrostatic charges, right? So same thing. So if you have two plates and you have a dielectric medium here, there is a charge. This is how the charge is. When you will connect this one, electrons flows from here to here. This is how a capacitor works, usual capacitor. So, you can have a high voltage, and when you will connect, immediately the current flow will start. So, the power will be very high.
But then initially to give those charges you have to apply some.
Why?
Otherwise how will it develop?
So, how you are getting electrostatic charges on your this one medium? You are getting some electrostatic.
Free electrons and all.
So, how you are getting electrostatic charges? That you have to tell me. If you will see, this is a charge here, so there will be negative charges. So, because of this, surface charges will be there. You have surface charges here. How you getting? Okay, when you put your, if you will get an electric current, right? If you will put your hand in some electric wire or something, you will get a shock, right? How the current pass through your body? What conduction? Oh, your body is like metal? It's a metal. It will allow the electrons to pass through your body. Your body is an insulator or a conductor. So, how you are getting shock? You can think about it. How you are getting an electric shock? You are going to try. Okay, that's a good thing. You can think about it actually. How you are getting charge? So, surface charges. The molecules will have some charges, right? So, when they will get aligned, you will get some. See, these type of resistive mediums, they have some surface charges because of ions, molecules, everything on the surface. So, because of that you will get a capacitor. If you have a dielectric medium, this can be air, Al2O3, these are different, air, Al2O3, something like that. Lot of dielectric mediums are there. It is a highly resistive medium, there won't be any passage of current. So, you have lot of surface charges. Because of the surface charges you can construct this one. And in a capacitor, so when you will immediately connect, you will get some current flow, right? So, the power of an capacitor is very high, power, because I into V is high, but the time, there is immediately it will discharge. So, there won't be any, there is no time, the amount of time it requires to discharge is very low. So, energy density of an capacitors are very low. See, so that is what this diagram shows. So, capacitor will be here, fuel cell will be here, because the voltage of a fuel cell is very low, its power is low, but it can deliver the charge or it can deliver the energy for a long, means it can give its capacity for a longer time. So, it is having a high energy density. Okay. So, capacitor. Then what is the importance of an electrochemical capacitors? What is an electrochemical capacitor? So, in an electrochemistry, actually you can have two different types of capacitors. One is a double layer capacitor, another one is a pseudo capacitors. Okay. So, double layer capacitance is happen when you will put an electrode inside a solution, okay, some charges will be developed and you have negative ions here. Opposite charges, this is called as double layer. If the process is only due to this one, only because of the charge distribution, opposite charge distribution between the electrode and the electrolyte. They are called as double layer capacitance. It's little, means it's a little more you can discuss on this one, but there is no time. So, and I will confuse you guys. So, there are different double layers are forming, different layers are there. So, here you can have an, simply if you are telling, because of the ions in the electrolyte, you can have a charge distribution on the electrode surface. So, because of this, when you will connect, immediately you can have a charge discharge. So, if you have two carbon electrodes, carbon is an example for a double layer capacitance. So, carbon, electrolyte, again carbon. Okay. So, here let it be I used an, for example, I used an NaCl solution or something, or H2SO4. So, you have, if I will run a CV, you can see that as a potential range, I can have an, if I will run a potential range, then I can have some capacitance due to the double layer formed on the electrode surface. This double layer will changes with the potential, because the number of charges, if I will apply more and more charges here, I will have more and more ions, right. So, you will have an double layer capacitance formed due to this particular process. This is called as double layer capacitance. For example, if in my carbon I have an Q node, okay, this Q node can give some reactions like this. Okay. Because of that, there is an electron transfer between my electrode and the electrolyte. So, there is a redox reaction is happening. So, then I have an, see this, see actually in a double layer capacitance you have a particular rectangle shape curve. This is called as a cyclic voltammogram. You are scanning a voltage and checking the current. Okay. So, in this case you have an increase in the current actually. This is due to this electron transfer from the electrode and the electrolyte along with your capacitance charges. So, this will, what happen is that this electron transfer is a process which have some time component. So, when you will discharge, the actually capacity is having something, capacity is something like extra charge for a longer time if you are charging out, right. So, if you will see this particular charge discharge curve, this one, for an EDLC it will be like very fast as compared to here. You can have a longer time or you have a larger capacity associated with the pseudo capacitors. Okay, it's in a simple term. I hope you guys get something. So, double layer charging is because of the ion distribution on the electrode surface and the electrolyte, and during a pseudo capacitor you have some electron transfer, and because of that electron transfer you have an extra charges available, and that charge, because that electron transfer is a time, it's having some time associated with that one, your capacitance will be improved. So, what happen is that it is as compared to the usual capacitors, this is an having some energy density, because it is, the process is slow, but you cannot have an higher voltage like an usual capacitors, because you cannot apply more than 2, maximum voltage you can get from an supercapacitor is 2 to 2.5, because right, if I am using water, I cannot go beyond something like 1.5 volt or something, because I have hydrogen evolution and oxygen evolution. Okay. So, if I am using a sulfuric acid solution, this is the range only I can go. Beyond that, I will have my electrolyte decomposing. So I will lose my electrolyte in the process. So I cannot go up to here. But in the case of a usual capacitor, you can go up to 100 volt also. Because you are depending upon your dielectric medium you are using. So voltage rating in an electrochemical capacitor is less as compared to the usual capacitors, but it is having a higher energy density because of the pseudo capacitance as well as a double layer formation. So it is having a higher energy density as compared to the usual capacitor. So this is they are called as supercapacitors. All electrochemical capacitors are called as supercapacitors. I hope you got some idea. So, and electrochemistry is also used for the sensor application. So this is a particular example. You might have seen this strip for checking the glucometers, right? It's actually working based on an electrochemistry actually. What happens is that in a glucose sensor, what are the strips you are having, right? That have an glucose oxidase. Okay, this glucose oxidase actually can convert the glucose into gluconic acid. During that process, hydrogen peroxide will be produced. This hydrogen peroxide will be detected by the platinum in the glucometer. So depending upon the, actually at the platinum electrode, this H2O2 will be oxidized to oxygen. So the current formed due to this oxidation of the hydrogen peroxide is detected, and that current will gives you the amount of glucose. That is how a glucose sensor, glucometer will work. So this is this is how there are a lot of other sensors like sensors for mercury in water. All these things, the major advantage of using an electrochemical system by using an electrochemistry is we can go up to a detection level, very low detection level, because you can get a current range of around nanoamperes also you can detect in a potentiometer. So you can have a very low detection also you can be possible. So with this I am just concluding. So it is an interdisciplinary, it contains lot of chemistries involved, like you for developing a material you need a good knowledge of the material science, even it can be like electrical engineering, and you can have some physics, chemistry. It is an interdisciplinary science, and it is and it have a wide variety of application, and it can be applied in the energy production, catalysis, synthesis. For example, now electrochemistry is used for the synthesis of biomolecules, especially for the pharmaceutical industry, where you can have a chiral molecule because you have a surface reaction, and which is very you can excitedly get particular optical isomers using electrochemical synthesis. So this is applied now. Electroorganic synthesis is one area which people are looking in the pharmaceutical industries, where they need a particular chiral molecule which is very active for a particular pharmaceutical importance. So they are trying to synthesize a particular chiral molecule using electrochemical method. Then biomedical application like lot of sensors, then metallurgy for the production of by electroplating, and then it is used lastly for the corrosion, where you can use for the in the factories where you need to know about the corrosion of many metals, and analytical chemistry, etc. So with this I am concluding. I hope you guys get something from this one. Any more doubts? Because many of the things like for example, what are the catalysis? Electrocatalysis is another area where we are developing many catalysts actually, right? Different methods we are using. So I cannot explain all the things here because it's a different area. It requires lot of explanation actually.